Okay, so now we come to one of the most important parts of our functions topic, one that often gets kind of overlooked because in some ways it should be prior knowledge, and that is factoring quadratics. Okay, and you probably have covered this in 9th and 10th grade, but many students, in my experience, seem to forget how to do it really. Apart from this simple version, possibly, when you have just 1x squared plus bx plus c. Okay, and you may remember that you need to find two numbers that multiply to get c and add to get b. C and b referring to these numbers here. Okay, and here's an example. Okay, could we factor x squared minus 2x minus 35? Well, can we find two numbers that add to get negative 2 and multiply to get negative 35? Well, sometimes in the trickier ones, you might want to list out the pairs of factors of c. For this one, there aren't really many, and it's quite simple to spot. It's going to be one of these first two, surely, and it is the first one. Okay, 5 plus negative 7 is negative 2. Okay, so we put those in to our brackets, and well, we should really check in any exam situation probably, and if you do check and expand, you do see why the two numbers should multiply to get negative 35 and why they should add to get negative 2. Okay, so next we move on to well, a harder version of this question, which is when we have more than one x squared. Okay, so ax squared plus bx plus c when a does not equal 1. So, well, for example, any of these that I've written here, 3x squared, 5x squared. Okay, and these are going to be a lot trickier because you can't really do it just by inspection, just by figuring out in your head. Well, unless they're quite simple ones. Any kind of bigger numbers, that quickly gets almost impossible for many students. So we need some kind of method, and I'm going to introduce one today. It's adapted from some other method that a student showed me once, but hopefully in a more streamlined manner. Okay, it might look a bit like a bit of a strange method, but I do think it's probably the fastest way of doing it. It's quite reliable once you get to do it. Okay, so the first step is to just take the coefficients. So take the 3, take the 1 from the 1x, and the minus 2. I'm going to label them A, B, and C. I don't have to label them every time. Okay, I'm going to take the first number and divide it by A. The second number I'm going to keep the same, and the third number, C, I'm going to multiply by A. And I get 1, 1, and negative 6. Next step would be to, which is quite similar to what we did before, I'm going to find two numbers that multiply to get the third number there and add to get the second number. So multiply to get negative 6, add to get 1. Okay, that is going to give me 3 and negative 2. Okay, now you can start to see this funnel shape, which is why I call it the funnel method. Okay, the next step, even stranger still, I'm going to write these two numbers as a fraction over a. So I'm going to take my a, which is 3, so I'm going to write 3 over 3 and minus 2 over 3. Next, I'm going to simplify this fraction as much as possible, okay, which will give me, I'm going to keep this as a fraction. Obviously I could just write 1, I'm going to write it as 1 over 1, and I can't simplify negative 2/3, so that stays the same. And now I've got my four numbers that I need. My denominators are going to be my coefficients of x, and my numerators are going to be my constants, what I add or subtract. So just for clarity, I've written 1x plus 1 and 3x minus 2. Obviously we can just say x plus 1. Okay, so that strange set of steps looks like it gives us our correct final answer. Okay, if we expand to check, yes, we do indeed get 3x squared plus x minus 2. Okay, so the main thing here is divide by a, stay the same, multiply by a, and find two numbers that multiply to get the third, and add to get the second. Make them as a fraction over a, simplify as much as possible, and then the final step, which is easy to mix up, is to write these fractions as denominator times x plus numerator in each bracket, one by one. Okay, so let's have another go. See how it's done one other time. Okay, next I have 5x squared minus 27x plus 10 equals 0. Okay, and this is the equation I'm solving now. I'm not just factoring a quadratic expression. I'm solving a quadratic equation, okay, which will involve an extra step at the end. Okay, so I'm going to write out my coefficients. 5 minus 27 and 10. Okay, I'm going to take a and divide it by a. I'm going to keep b the same. I'm going to take c and multiply it by a, so 50. Now this step can still be quite tricky, but you will get used to it. So yeah, I need to multiply to get 50 and add to get negative 27, so that's negative 25 and negative 2. Write it as a fraction over 5, fraction over a. Simplify as much as possible. Again, I'm going to keep it as over 1, otherwise it kind of confuses things. And what I see is I get x minus 5 times 5x minus 2. Again, I could expand and it would be perfectly fine. Okay, but this time I'm solving it equal to 0. So I just got my two brackets on the left hand side now that equal 0. Okay, and either the first one should equal 0 or the second one should equal 0. Okay, to make the first bracket equal 0, x would have to equal 5. To make the second bracket equal 0, x would have to equal 2/5. Okay, that might take a few more steps to solve. Okay, and this is because, okay, if the first bracket is 0, it doesn't matter what the second bracket equals, because 0 times anything equals 0. Okay, and the same thing the other way around. Okay, so that's how we get our two answers if we want to solve a quadratic equation through factoring and through using the funnel method. Okay, so this seemingly is working very well. Is there any way that it does not work? And yes, there is one small exception. Okay, if I try to go through the funnel method very quickly with this example, okay, I don't need to go through the steps again here, because we're going to run into an error in a second. Okay, so I put as a fraction over a, and well, I write out my brackets, and that looks fine, except actually if I start expanding it to check, I get 3x squared. Well, that's wrong, because I should have 6x squared. So what's happened here? Well, this is something that you need to be checking in every single quadratic factoring problem, is whether you can factor out a constant. Okay, so just like if you wanted to factor out something from a linear expression, like 4x plus 10, you could factor out 2, it would be 2 times 2x plus 5. You can do exactly the same thing here. You can factor out a constant, and in this case 2. So 2 times 3x squared minus 11x minus 20, that should be. Hang on, need to change that. Yeah, minus 20, because I've divided it by 2. Okay, now I can just use the funnel method on the quadratic expression that's inside the bracket. Okay, so write the 3 coefficients out, divide by a, stay the same, multiply by a, 2 numbers that multiply to get negative 60 and add to get negative 11. Okay, put them as a fraction over a, simplify as much as possible, and I get my two brackets, which again seem like I get 3x squared, but no, I've actually factored out a 2 already, and I can take that 2 and I can put that as a multiplier in front of my two brackets once more. Okay, now if I expanded this, I would get 3x squared, but times 2, and I would get my 6x squared. And you could see that I get minus 5 times 4, minus 20 times 2 would give me my minus 40. So that looks fine. Okay, that is the funnel method. Okay, it might take 4 or 5 times to get going with it, and it might seem a little bit slow at first, but once you've mastered it, it really is, I'd say, the fastest way of factoring quadratics when a does not equal 1. Okay, when a does equal 1, still you can just use that method that we wrote